So today we're going to be taking a look at day 14. So the first thing is multiply. So hopefully you guys remember, if we're multiplying, we got 2x plus 3 and x minus 5 on the outside. So we have 2x squared, 3x, negative 5x, negative 5 times 3 is negative 15. So our grand total is 2x squared minus 2x minus 15. So the first thing we're going to do is take a look at a couple of word problems here. A ball is hit in the air with an upward velocity of 48 feet per second. Its height h in feet after t seconds is given for the function. What is the starting height of the ball? Well, again, that's when time equals 0. So if we plugged in time equals 0, negative 16 times 0 squared plus 48 times 0 plus 4, it would be at a height of 4 feet. If we look at Desmos and graph this, negative 16x squared, and I already forgot what the next part was, plus 48x plus 4, again, it comes up here. We see our parabola here, and it comes up as our y-intercept. So the second question, what height will the ball be when 2 seconds have passed? So two different ways we can fill it out. 2 seconds, negative 16 times 2 squared, plus 48 times 2 plus 4. So we can go back here, negative 16 times 2 squared, plus 48 times 2 plus 4, 128. Or if I graph the equation y equals 2, and I guess we have to see where x equals 2. Sorry, so I want an x equals 2 because x is our time. And I forgot 48 times 2. Why is this not working? X equals 2. Did I have this? Oh, I see. I got times positive 4. Let's see if I just do times 2 plus 4. There we go. Then I end up with that. At 2 seconds, it's at 36. So we'd have 36 feet. So if we were to sketch a graph, I would ask that you have the y-intercept of 0, 4. Let's see what our max is and just put some of these important points on there. So the height, 1.5 and 40 is that vertex. Then what are those x-intercepts? If we go down, so negative 0.8 and 3.08. So negative 0.8 and 3.8 and 0. Just so we have those coordinates. And how many seconds will it reach its max height? So seconds is our x. So at 1.5 seconds, and that height is at 40 feet. And then when will it reach the ground? Well, what's max height is 0 at 3.8 feet. So the next one we're going to look at, we're going to see if we can do some of these again algebraically, but also using Desmos. Landon jumps off a cliff into water. The height he travels can be represented by, here's a function. So again, we have our parabola. At what height did he jump? So when time equals 0, so our y-intercept. Well, if we plug in, that should be 480. After 1 second, negative 16 times 1 squared, 16 times 1 plus 480. So let's graph this. So negative 16x squared plus 16x plus 480. So we could, let's do a scale. maybe I want to count by 10. And let's go up to 500. What does this look like? Okay, so that works. So let's see. Yeah, we got 480. Maybe zoom in, see 41. But I bet if I put 480, it would be there. So let's see. What is the highest point? So it was 0.5 and 484. So it would be his highest point is 484 feet at 0.5 seconds. And then how many seconds did it take for him to hit the water? So if we go back here, hit the water, when does he come down? When's our y-intercept, our x-intercept? At 6 seconds. And let's take a look at this last one, a profit equation here. A company sells fidgets. The amount of profit, y, made by the company is related to selling the widget. Use this equation right here. Use this equation, what price should be sold for and what is the max to make the maximum profit. So let's graph that. So we have negative x squared plus 72x plus 458. All right, so the max is right up here. So 361754. So our vertex is 361754. So what does that mean? Selling price is X. So the price would be $36 and our max profit would be $1,754.